For decades, the Bermuda Triangle has captured imaginations with stories of vanishing planes and ships, but now new scientific theory claims to have finally answered.
Scientists operating a remotely piloted underwater vehicle in the North Atlantic have returned footage from the seafloor of the Bermuda Triangle that is raising urgent new questions about what lies beneath one of the most notorious stretches of ocean on Earth. What the camera sent back from 700 meters below the surface wasn't what anyone on that research vessel expected to find. And once the footage was reviewed, no one on board could agree on what exactly they were looking at. The drone had been in the water for less than 2 hours. It was supposed to be a routine survey, catalog some topography, map the seafloor, log the data, go home. Instead, the footage showed stone formations that had no business being where they were. Shipwrecks. Not one, not two, but clustered, as though the sea had been collecting them. Rusted anchors half buried in silt, broken masts reaching up from the dark like arms. And then, between the wreckage, something that made the operator pull back the controls and hold the drone completely still.
They remain convinced that this is a dangerous area, all thanks to highly unusual seaweed.
But researchers have discovered that Bermuda has one major difference.
Pale shapes, resting against the debris. The camera zoomed in. They were bones. This was the Bermuda Triangle, 500,000 square miles of Atlantic Ocean, stretching between Miami, Bermuda, and Puerto Rico. The most famous body of water in the world. The place that swallowed ships whole and gave back nothing. And down there, in the silence and the pressure and the absolute dark, it had kept its collection. But what the drone found that day was only the beginning, because once the researchers began cross-referencing the footage with what we already know about this place, the science, the history, the physics, the real mystery wasn't the wreckage at all. It was something far older and far harder to explain. To understand why any of this matters, you need to understand what the Bermuda Triangle actually is. Not the myth, not the movies. The real geography, and the real science that makes it genuinely strange, even when you strip away the fiction. The triangle is defined by 3 points: Miami on the west, Bermuda to the north, San Juan, Puerto Rico to the south. The enclosed ocean covers somewhere between 500,000 and 1.5 million square miles, depending on which researchers you ask. It is not a recognized geographic designation by the U.S. Board on Geographic Names. The U.S. Coast Guard does not treat it as an official zone of hazard. The insurance market, Lloyd's of London, after examining the records, concluded that ships are not lost there at a disproportionate rate compared to any other heavily trafficked stretch of ocean. So the rational case is strong. The area sees extreme weather, hurricanes, waterspouts. The Gulf Stream, which runs through the region, is one of the most powerful ocean currents on Earth, strong enough to scatter wreckage hundreds of miles from where a vessel went down. There are steep underwater drop-offs just beyond the continental shelf. The region is one of the busiest shipping corridors in the world, which statistically guarantees more incidents. And since 1930, more than 325 aircraft and over 1,200 ships have disappeared, crashed, or sunk there. A figure that sounds alarming until you factor in that traffic volume. Most scientists will tell you it adds up. Human error, weather, geography. But then you look at the individual cases, and the rational framework starts to strain. Picture the afternoon of December 5th, 1945. The Florida coast glitters to the west. The sea is calm enough. At 2:10 in the afternoon, 5 TBM Avenger torpedo bombers take off from Naval Air Station Fort Lauderdale on a routine training exercise. The flight leader is Lieutenant Charles Carroll Taylor, an experienced pilot, a combat veteran, a man with over 2,500 hours in the air. He has done this route before. There is nothing unusual about the day. 90 minutes later, everything goes wrong. Taylor's compass stops working. Then the backup compass stops working. Then the compasses on the other 4 planes begin failing. Taylor radios back. "We cannot see land. We don't know where we are." The search and rescue crews launch. One of the rescue planes, a PBM Mariner carrying 13 men, disappears within 30 minutes of takeoff. A merchant vessel in the area reports a sudden explosion in the sky. No wreckage is recovered from the Mariner.
The Bermuda Triangle has captured imaginations with stories of vanished planes and ships, but now a new scientific theory claims to finally have the answer.
A Navy Board of Investigation poured over 611 pages of testimony and records. Their conclusion, after everything? Causes or reasons unknown. The search covered 300,000 square miles. Not a single body, not a single piece of confirmed wreckage from Flight 19. 27 men, 6 aircraft, gone. That alone would be enough to keep researchers asking questions. But the Flight 19 case isn't even the most inexplicable thing about this ocean. When geochemist Richard McIver began analyzing the seafloor beneath the triangle in the early 1980s, he found something that reframed the entire conversation. The ground under the Bermuda Triangle isn't like ground anywhere else. The team reviewing the drone footage that night sat in silence after the first full playback. The lead oceanographer, according to accounts of the expedition, asked for it to be run again from the beginning, then a third time. Nobody reached for coffee. Nobody checked their phone. They just watched. In 1981, Richard McIver published a paper that changed how a small but serious community of geoscientists thought about the Bermuda Triangle. McIver wasn't a paranormal investigator. He was a geochemist. His paper appeared in the AAPG Explorer, a petroleum industry publication. His argument was grounded, specific, and deeply uncomfortable. Beneath the ocean floor in this region, McIver found, lie vast deposits of methane hydrate. These are crystalline structures, part ice, part gas, that form under the intense cold and pressure of deep water. They look like ice, they behave like ice, but inside each crystal lattice, locked in molecular cages, is concentrated methane gas. The U.S. Geological Survey has confirmed that one of the most substantial methane hydrate deposits in the Atlantic lies along Blake Ridge, a submarine plateau that begins just north of the Bermuda Triangle and extends south into its boundaries. Benjamin Frampus, an earth scientist at Southern Methodist University, has described the deposit as one of the largest methane hydrate provinces on the entire U.S. Atlantic continental margin. Here is where McIver's theory becomes alarming. Methane hydrates are stable until they aren't. A seafloor landslide, a shift in temperature, a pressure change. Any of these can cause the crystalline structure to destabilize. When it does, it doesn't simply melt, it erupts. The hydrate breaks apart and releases enormous volumes of methane gas simultaneously. The bubbles rise through the water column at speed. A 2003 study published in the American Journal of Physics tested what happens to a ship above such a bubble. Researchers built a scale model of a ship's hull. They released a large gas bubble beneath it in a water tank. The results were unambiguous. The bubble reduced the density of the water so rapidly that the vessel lost buoyancy instantly and sank, not gradually, but in seconds. The hull didn't capsize, it just went down. The data was clear. The implications were anything but. Because if this mechanism works, it doesn't just explain why ships disappear. It explains why they disappear without distress calls, without wreckage, without oil slicks. A vessel caught above a methane blowout wouldn't have time to transmit anything. The crew wouldn't have time to reach the lifeboats. The ship would be underwater in under a minute, pulled down by the gas-saturated water rushing in from below, with the sediment from the eruption settling over the hull within hours. No trace, no explanation, just an empty ocean. And this is the detail that keeps researchers up at night. According to the USGS, the seafloor beneath the Bermuda Triangle has not had a major methane eruption in approximately 15,000 years. Not confirmed in recent history, but the deposits are still there. They haven't gone anywhere. The question isn't whether the mechanism exists. A laboratory already proved it does. The question is whether it's happened before, and whether anyone could tell if it had. Outside the porthole of the research vessel, the Atlantic was flat and dark and completely unreadable. You would never know, looking at it, what was underneath. If you want to understand how deeply this seafloor has been holding its secrets, don't start with Flight 19. Start with the SS Cotopaxi. The Cotopaxi was a cargo steamship. On December 1, 1925, she departed Charleston, South Carolina, carrying a crew of 32 men and a hold full of coal. She was bound for Havana, Cuba. The route took her directly through the Bermuda Triangle. A distress signal was picked up on December 1st by a station in Jacksonville, Florida. Then, nothing. No wreckage, no bodies, no cargo. The Cotopaxi simply ceased to exist. For nearly a century, it was one of the Triangle's most cited unsolved disappearances. Then, marine biologist and shipwreck explorer Michael Barnett began working the case. Barnett wasn't chasing legends. He was applying rigorous forensic methodology to maritime records, cross-referencing historical distress signal coordinates with known underwater topography, matching hull dimensions against sonar profiles of existing wrecks. His team deployed an ROV, a remotely operated vehicle, nicknamed Baxter, which could reach depths far beyond the range of any diver. What Baxter found, near the coordinates recorded in the 1925 distress signal off the coast of St. Augustine, Florida, was a wreck that locals had long called the Bear Wreck. Nobody had properly identified it. Barnett's team examined the constructive features, the hull layout, the deck fixtures, the structural dimensions. The similarities to the documented specifications of the Cotopaxi were striking enough that Barnett went public. He believes the Bear Wreck is the Cotopaxi, a cargo ship missing for 96 years, sitting in plain sight on the Atlantic floor. But notice what Barnett's discovery doesn't resolve. It tells us where the Cotopaxi is. It doesn't tell us what happened to her. She is sitting at the bottom of this ocean, intact enough to be identified, and her 32 crew members have never been found. No one knows what hit her. No one knows how fast she went down. To understand why this matters, we need to step back and look at the pattern. The Cotopaxi is not an isolated case. Since the early 20th century, researchers tracking maritime records have identified a clustering effect in this region. Ships not just disappearing, but disappearing in similar ways, quickly, without debris fields, without bodies, without the oil slicks that any sinking vessel should leave on the surface. When Lloyd's of London concluded that the Triangle wasn't statistically more dangerous than other shipping lanes, that finding was based on rate, on whether more ships sank per mile of ocean. It said nothing about the character of the sinkings, the how, the speed, the completeness of the disappearances. Something about the way things vanish here is different, and the drone footage, 700 meters down, was beginning to suggest why. If you want a chance to support this channel's continued work investigating mysteries like this one, a quick like genuinely makes a real difference. Now, back to what the drone found, because this is where things become genuinely difficult to categorize. The seafloor beneath the Bermuda Triangle is not a flat, featureless plain. The continental shelf drops off steeply just beyond the Florida coast, from relatively shallow water to depths of over 4,000 meters in a geological eye blink. The Puerto Rico Trench, the deepest point in the Atlantic Ocean, sits at the southeastern boundary of the triangle at 8,376 meters. The underwater topography includes vast trenches, submerged ridges, seamounts, and what oceanographers have identified as complex current systems generated by the interaction of the Gulf Stream with these bottom features. And then there are the blue holes. Blue holes are underwater cave systems, vertical shafts plunging into the seafloor, sometimes hundreds of meters deep, carved over millennia by dissolution of carbonate rock. The Bahamas, which sit within the Bermuda Triangle's boundaries, sit atop one of the world's most extensive carbonate platforms. Researchers have documented dozens of blue holes in this region. Some are shallow enough for divers, some are not. The largest confirmed blue hole in the world, the Sansha Yongli blue hole in the South China Sea, descends 300 meters straight down. But researchers believe some Atlantic blue holes in this region may reach comparable depths. The problem is that they haven't all been fully mapped. The seafloor here is, in significant stretches, less completely charted than the surface of the moon. This is not metaphor. The National Oceanic and Atmospheric Administration, NOAA, has estimated that more than 80% of Earth's oceans remain unmapped at high resolution. The seafloor beneath the most mythologized stretch of ocean on Earth contains geological features we have never fully cataloged. The The drone footage showed stone formations at 700 meters depth. The debate among researchers reviewing that footage centered on a single question. Were those formations natural geological structures, the exposed limestone shelves and carbonate ridges that characterize this seafloor, or were they something else? Because a small but vocal group of researchers noted that the arrangement of certain formations wasn't consistent with the known patterns of natural carbonate deposition in this region. They weren't willing to say what that meant, not publicly, but the clustering of wrecks around those formations was harder to dismiss. At this point in the expedition, according to accounts, the decision was made to send the drone deeper, toward the stone structures. The team gathered around the monitors. The feed went to static 3 times before stabilizing. Nobody spoke. There is one aspect of the Bermuda Triangle phenomenon that skeptics have the most difficulty addressing. It isn't the shipwrecks, it isn't the methane, it is the compasses. Christopher Columbus noted it first, in 1492, sailing through the region on his initial voyage to the New World. Columbus recorded in his log that his compass was behaving abnormally, giving readings that differed from what star navigation suggested they should be. He also noted a large flame that appeared to fall into the sea one night, and a mysterious light on the horizon days later. Columbus was a skilled and methodical navigator. He documented these anomalies carefully, without sensationalizing them, because they posed a genuine practical problem for his crew. Nearly 5 centuries later, Lieutenant Charles Carroll Taylor's compasses stopped working over the same ocean. The standard explanation is magnetic variation, the fact that magnetic north and geographic north are not the same point, and that this discrepancy shifts over time and varies by location. The Bermuda Triangle happens to be one of the few places on Earth where magnetic north and geographic north align closely, which can actually confuse navigators who haven't accounted for it in their calculations, because the correction they expect to apply isn't needed. Disoriented pilots, compensating for a variation that isn't there, can fly in completely the wrong direction. This explanation is rational. It's well documented. Most navigation experts accept it as a primary contributor to the Triangle's aviation incidents, but it doesn't fully account for what Taylor experienced. Multiple independent compasses on 5 separate aircraft, all failing simultaneously. Not drifting, failing, going dead, or spinning freely. That isn't magnetic variation. That's something else. Helen Chersky, an oceanographer and physicist at University College London, has described the Triangle's methane deposits as capable of altering the local atmospheric chemistry above a blowout. Methane gas rising to the surface changes air density. It can interfere with engine combustion in aircraft with air-aspirated engines. And here is the less discussed effect: a massive release of magnetized particles from destabilized seafloor sediment. The kind of sediment that surrounds methane hydrate deposits can theoretically generate localized electromagnetic interference. Theoretically is doing a lot of work in that sentence. It hasn't been confirmed. The physics is plausible. The evidence for it in this specific location is limited. But Taylor's compasses didn't drift, they died. And the rescue plane sent to find him disappeared too. At this point, the researchers assumed they had their answer. They were wrong. Here is where the story has to make a turn. Not away from the science, into it. Because when you pull all of this together, a different picture starts to emerge. Let's say the methane hydrate theory is correct. Let's say, for the sake of argument, that periodic eruptions from the Blake Ridge deposits and surrounding seafloor have been swallowing ships for centuries. This would explain the sudden disappearances, the lack of debris, the speed, the silence. But it still doesn't explain the compasses, and it doesn't explain why the clustering of disappearances in this region has a historical pattern that predates modern shipping by centuries. Portuguese navigators called this stretch of water the Sea of Fear in the early 1400s. Sailors who transited it regularly reported encounters with strange lights, compass anomalies, and disappearances that couldn't be explained by the weather conditions on record. This wasn't yet the age of mass Atlantic shipping. The traffic volume was low. The disappearances shouldn't have been notable enough to earn the region a reputation, but they were, for 600 years. Some researchers, and it's important to be clear that this sits firmly in the territory of speculation, have proposed that the seafloor beneath the Bermuda Triangle may contain structural anomalies that interact with Earth's geomagnetic field in unusual ways. The carbonate platforms beneath the Bahamas contain mineral deposits with known magnetic properties. The interaction of deep ocean current systems with these geological features creates complex electromagnetic environments. Whether any of that rises to the level of the phenomena reported over the centuries is a question that current science cannot definitively answer. One controversial theory, advanced by a minority of oceanographers, suggests that the concentration of blue holes and cave systems in this region creates a series of underwater suction events, rapid water movement through subterranean passages triggered by tidal and current shifts. The physics works on a small scale. Whether it scales to the size required to pull down a full cargo vessel is another matter. The theory has not been peer-reviewed in any mainstream journal. Then there's the view from outside science entirely. For as long as the Bermuda Triangle has held its reputation, a subset of researchers, geographers, archaeologists, fringe historians, have pointed to the Bahama Banks, the shallow carbonate platforms within the triangle, and asked a question that mainstream science declines to take seriously. Is it possible that what we call the seafloor here is, in some areas, something built? The Bimini Road, a formation of flat-edged stones discovered in 1968 near North Bimini in the Bahamas, has been the subject of ongoing debate for more than 50 years. Geologists who have examined it describe it as a natural beach rock formation, stones fractured into rectilinear shapes by the natural weathering of carbonate limestone. Other researchers have noted that the regular spacing and alignment of certain sections is statistically unusual for natural fracture patterns. It has not been proven artificial, but it has also never been definitively explained by the geological models used to describe it. Of course, there are simpler explanations for almost everything in the triangle: weather, traffic, human error, bad record keeping. And the simpler explanations account for the vast majority of documented incidents with reasonable accuracy. The mystery persists not because the rational framework fails entirely, it's because at the edges of that framework, there are cases it cannot fully absorb. Cases like Flight 19, cases like the pattern of compass failures, cases like the drone footage at 700 meters showing wreckage clustered around formations that behave like landmarks. The ocean doesn't have landmarks, unless something put them there. There's a moment in deep-sea exploration that researchers describe in similar terms, regardless of where in the world they're working. It's the moment when the ROV reaches a depth where light from the surface is completely gone. Not dim, not filtered, gone. The illumination from that point on comes entirely from what you brought with you. Artificial, temporary, a small envelope of visibility in something that goes on much further than you can see. Researchers describe that moment as clarifying. You stop thinking about the equipment. You stop thinking about the protocol. You just look at what's in front of the camera, and you try to understand what you're seeing. The drone footage from the Bermuda Triangle, whatever conclusions you draw from it, does something similar to the viewer. It strips away the myth. Not because the myth is confirmed, but because the reality underneath it is strange enough on its own. Stone formations, clustered wrecks, bones resting in the silt where the pressure has preserved them past any right to exist. These aren't the props of a ghost story. They're what actually happens when something goes wrong in the deep Atlantic. Ships go down fast. The current carries away what floats. The sediment eventually covers what doesn't. And down there, in the dark, the record is kept in a way that nothing on the surface preserves. The triangle has been absorbing vessels and aircraft and human beings for at least 5 centuries of recorded Western history, probably longer. The seafloor beneath it is an archive, imperfect, incomplete, subject to decay and burial, but an archive nonetheless. The drone reached a page of that archive at 700 meters. It captured stone structures and rusted hulls and bones. What it didn't capture, what no instrument we have built can yet capture, is the full picture of what happened to every vessel whose remains weren't in that frame. The ocean is very large. Our drones go where we point them, and the triangle is mostly darkness that hasn't been pointed at yet. What happened to the men of Flight 19 is unknown. The Navy's official record says so. What happened to the Cotopaxi's 32 crew is unknown. What process, geological, meteorological, electromagnetic, or something we haven't named yet, has made this stretch of ocean so consistently, so completely, consumptive of the things humans send into it, across 6 centuries of recorded history, is a question that one drone, reaching one point at 700 meters on one day, cannot answer. But it asks the question in a way that footage hasn't before. And some questions, once asked with that level of clarity, are very hard to stop thinking about. The ocean floor is being mapped faster now than at any point in human history. New autonomous underwater vehicles, new sonar systems, new pressure tolerances and remote technology. The pace of deep-sea survey has increased enormously in the last decade, and yet, over 80% of Earth's ocean floor remains uncharted at useful resolution. The NOAA estimates that at the current pace of exploration, completing a comprehensive map of the world's ocean floor would take several more decades. The Bermuda Triangle, over 500,000 square miles of North Atlantic seafloor, is no exception. The drone footage showed us one small piece of what's down there: stone formations, wrecked ships, human remains, a concentration of tragedy at a single set of coordinates that raises more questions than it resolves. Michael Barnett, the marine biologist who deployed his rove Baxter to find the Cotopaxi, said something after his expedition that stays with you. He noted that identifying the wreck was significant not just for what it told us about that ship, but for what it tells us about everything we haven't yet found. By knowing what this aircraft is, Barnett said about a separate Avenger discovery, we know where Flight 19 isn't. By knowing what we found, we know the shape of what we haven't. The Bermuda Triangle has been telling us for 600 years that there is something in that ocean we don't understand. We've been arguing ever since about whether the signal is real. The drone went down. It came back with footage. The researchers watched it 3 times in silence. What is in the rest of that ocean floor? In the 499,999 square miles we haven't sent a drone to yet? And what is it still keeping?